So in this video we'll look at example 2. So we're asked, what power can be transmitted by a steel propeller shaft 50 millimeters in diameter at a speed of 300 RPM if the shear stress is limited to 90 meganewtons per meter squared? And we're told that the answer is 69 kilowatts. Alright, so we'll begin by including the formulae that we're going to use for the torsion problems, and we're just going to highlight the information that we're given. So we're told that the shaft has a diameter of 50 millimeters, so it doesn't have an internal diameter, so this small d is 0, so this will be 50 millimeters. The RPM is 300, so n here will be 300. And the shear stress is 90 meganewtons, so the shear stress here will be 90. So I've included those in. So there's the shaft, 0.05, there's the RPM, 300, there's the 90 meganewtons for the shear stress, and the radius of the shaft, well, the radius is half the diameter, so that will be half of 50 millimeters, which is 25 millimeters. Alright, so we'll go ahead and put these into our calculators and we'll get these values. So we're going to start with J. Okay, so J is, so it's pi multiplied by 0.05, that's to the power of 4, and that's all over 32. And 6.13 by 10 to the power minus 7, just hit the engineering button. So it's 613 by 10 to the power minus 9 meters per meters to the power of 4. Okay, so 613 by 10 to the power minus 9 meters by 10 to the 4. Okay, omega then is 300. Multiplied by 2, multiplied by pi, and we're going to divide that then by 60, and we get 31.42. 31.42. I'm going to take this J value here and stick it in here, and when I rearrange that, that torque then just becomes J times the shear stress all over the radius. So instead of J, I'm putting in my 613 by 10 to the power 9. So if I calculate that, so it's 613 by 10 to the power minus 9. I'm going to multiply that by, so it's 90 meganewtons all over 25 millimeters, which is 0.025 meters, and I get 2206.8, which is what I have here. I'll just minimize this. 2206.8, yeah. Okay, now I want to get the power. The power is torque by omega. We'll just calculate what the torque, maximum torque value is. We have an omega, so the power is torque times omega. The torque is 2206.8. That's the decimal point there. That's 31.42, and when I multiply that out, so I have 2206.8. I'm going to multiply that by 31.42. That gives me 69.4 kilowatts. To 69.4 kilowatts. Okay, so I'm missing a decimal point. Let me put that in. Point there. There should be a decimal point there. Okay, so that's my answer.